In this example, we're asked to find an angle measure. And here's the idea. It's a multiple choice question. And we're told that the triangle RST forms part of the front of the cabin as shown at the left. The question is, what is the measure of angle S? And our options are A, 55 degrees, B, 70 degrees, C, 125 degrees, and D, 110 degrees. So we're going to use some of this information that we know about triangles, and more specifically the interior angle sum of a triangle. We know that all three angles of a triangle will add up to 180 degrees. So we'll use that information in order to determine this unknown angle measure. So looking more closely at the figure, we see that both of the base angles, so angles R and T, are 55 degrees. 55 plus 55 equals 110. So whatever our angle S measures plus 110 degrees must equal 180 degrees. Without even doing the arithmetic or algebra, I know that that answer is 70 degrees. But this was a fairly simple and straightforward question with nice numbers that rounded off evenly. In order to do a problem that's more complicated, we may have to use some algebra, or this could be a very good way to check our work. So let's check out the book's example of how to do this using algebra. We see the measure of angle R plus the measure of angle S plus the measure of angle T equals 180 degrees. That's by our interior angle sum property that we've discussed. So substitute in the two measurements we know, 55 degrees and 55 degrees, into the formula, and we get that 55 degrees plus the measure of angle S plus 55 degrees equals 180 degrees. Combining like terms, we find then that the measure of angle S plus 110 degrees equals 180 degrees. Further simplifying, using SADMAP in order to isolate the variable we'd like to solve for, in this case our variable is the measure of angle S, we subtract 110 degrees from both sides of the equation to find that the measure of angle S is 70 degrees. A quick check would be just to add up. What is 70 plus 55 plus 55? If that equals 180, then we're in business. That leads us to answer choice B, 70 degrees. Here's your quick check problem. Given the triangle at the right, what is the measure of angle E in the triangle DEF? So moving along after example problem number 1, here we have some more information and a new key concept. If all pairs of corresponding angles of two triangles are congruent, then the triangles have the same shape and the triangles are similar. In the diagram at the left, angle F is congruent to angle X and angle G is congruent to angle Y. What about the third pair of corresponding angles? By using the angle sum of a triangle, you can determine that the measure of angle H equals 68 degrees and the measure of angle Z equals 68 degrees. Because all three pairs of corresponding angles are congruent, triangle FGH is similar to triangle XYZ. This example shows that if two pairs of corresponding angles of two triangles are congruent, then the third pair of corresponding angles must also be congruent, and the triangles are similar. And the key concept based upon this is the angle-angle similarity. If two angles of one triangle are congruent to the corresponding angles of another triangle, then the triangles are similar. Another example problem, example 2, regarding similar triangles. The directions say to show that the pair of triangles is similar. So we know about this angle-angle similarity And we're going to use that in order to show that these two triangles are similar. So we have a triangle at the right, a triangle PQR, with two known angle measures, 91 degrees and 37 degrees, and the triangle KLM below, with one angle measure of 91 degrees and one angle measure of 52 degrees. So thinking intuitively, what we need to do is to determine whether or not angle R measures 52 degrees, or whether or not angle M measures 37 degrees. Note what we know about these two triangles. We know that angle P and angle L, those two are congruent. Therefore, if using the interior angle sum property of triangles, we can identify that the third angles are congruent, then we can say that these two triangles are similar. Take a look at the work on the left. Step 1, it says to use the angle sum of a triangle to find the measure of angle R. Well, that can be done quickly and easily. 91 plus 37, 128. Subtract that amount from 180 degrees to find that we have 52 degrees remaining for angle R. That's truly all that we need to know in order to show that these two triangles are similar. But step 2 shows us how to use the angle similarity. Angle P is congruent to angle L. We know that because each measures 91 degrees. Angle R is congruent to angle K. We know that because each measures 52 degrees. Therefore, triangle PQR is similar to triangle LMK by the angle-angle similarity. A quick test prep tip before we get to your quick check problem. There's often more than one way to show that two triangles are similar. For example, you could have started by finding the measure of angle M instead of the measure of angle R. So here's your quick check problem for this example. Show that each pair of triangles is similar. Note there's a part A and B. Part B is interesting, and we'll talk more about that sort of setup very much in the future. And this is the Check Your Understanding assignment in order to ensure that you've learned from each of these examples and understand the basic concepts that you'll need to move ahead successfully. This is here for your use. You can screenshot, print, or simply look at this page while you complete your work on separate paper.